What were we discussing last time? No. Sahana, Benny.
Sir.
Yeah. Do you remember at all what we were doing last time?
We were plotting equations of circle on the graph.
Yeah. What else after that? We talked about sine wave. Is that right, Sahana?
Sir.
Do you remember how sine wave is related to the circle? If a planet or an insect is moving in a round and round, then how do you get wave from there? If something is going round and round, how do you get how do you get oscillation from there? Oscillation means back and forth, back and forth. How do you get that? Back and forth. Does anyone remember? If you look at something going in round and round in a circle, then if you look at either the vertical direction or the horizontal direction, what will happen? It will be going like a wave, like a spring. Is that right, Sana?
Sir.
Madhumita Pujar, do you remember how exactly we get wave? We get like spring motion or like up and down motion from thing going in a circle? Madhumita? Who remembers that? If I see something going round and round in a circle, then I should look at its coordinate. Which coordinate should I look at? X coordinate or Y coordinate?
I, sir.
Anything. You can look at either Y coordinate or X coordinate. Either way. Even if you look at the X coordinate, what will happen? What will you see? What will you see? If something is going in a circle like this, if I look at the X coordinate, what will I see? It will be going left, right, correct? Like this, left, right. And same with the Y coordinate. I go up, down. And then if you plot it as a function of time, what will you see? You will see a sine wave like this. Okay? Do you remember that? Do people remember that? Let me ask just to make sure, since I'm not hearing from anyone, I just want to know if people remember connection between sine wave and circular motion. Okay, so instant poll launch 30 seconds. Mark A if you understand how something moving in a circle, then if you look at the y-axis, it will look like a sine wave, up and down. If you agree, if you understand, let me create a new poll. Okay. Do you understand how object moving in circle produces looks like sine wave if you look at y coordinate over time? Okay. Okay. A means yes and B means A yes, B no. If B no. Okay, just mark A if yes, then otherwise B no. Launch poll, 30 seconds. Okay, so this is not correct answer. Just tell me if you understand or just to understand or not understand. Okay, if you understand how something moving in a circle is going up and down like a sine wave, then say yes. If you don't understand, then mark B. Okay. Okay. Forget the correct. There's no correct answer. Okay, I'm just forget the correct answer. Only 9 people marked. Okay, 7 people said no, and 2 people said yes. Okay. Let me see who those who didn't understand. Okay, so let me go to Sahana, Sachin, Aishwarya, Pooja, and Sanjana Chittapakke said no. Okay, so let's go to let me go to Pooja Hubli. Pooja Hubli, can you unmute your mic? Any one of those who said no, just raise your hand or open your mic. Pooja, Aishwarya, any of them. How about Pooja Hubli? Can you unmute your mic? Pooja?
Yes, sir.
Yeah. So you said you didn't understand, right? So can you tell me a little more? Just help me understand a little bit which part was difficult. So do you understand the question, first of all? That something is going round and round in a circle. And why, if you look at it in the y coordinate of that, so the vertical direction, then it looks like a sine wave. Did you understand the question, or which part did you not? Which part are we having difficulty with, Pooja?
So I didn't understand how it looks like sine wave.
Okay, good. Okay, good that you told that. Okay, so because I think a lot of people have not understood, and thanks for thanks for saying that, because then a lot of other people would understand. So Pooja, now tell me, if an object is going round and round like this, and if you just look at it in the vertical direction, right, how much up or down it is, then how will it look? How will it look? Just look at the up or down direction.
Up and
What is the
down.
vertical? Sorry, repeat that.
So
I didn't hear that.
if we see vertical, it looks like
Uh-huh.
up and down.
Yeah. Now, vertical direction, distance from center is called what? Which coordinate is that? The vertical how much high or how much low it is given by which coordinate?
Why?
Y coordinate, exactly, the y-axis. Okay. So if you look at the value in the y-axis, then what will you see? Will you see it going up and down in the y-axis? Pooja?
Yes, sir.
Okay. So will you see the y coordinate becoming positive and then coming back to zero and then negative and then coming back to zero and then positive and coming back to new? Like that. Will you see that?
Yes, sir.
Okay. So if you plot as a function of time, that means if you make the x-axis as a time and then you look at the y coordinate in the y-axis, then what will you see? How will the graph look, Pooja? Will you see that as time increases, it goes up, and then it comes back down to zero, and then becomes negative, and then up? Do you see that? It'll go like this, like this, like this. Do you see that?
Waves, sir.
Yes?
Waves, sir.
Wave, yeah. So do you understand why the y coordinate, if you look at how the y coordinate changes over time, it looks like a wave? Do you understand that part, Pooja?
Yes, sir.
Okay. So remember last time we said that think that the object is going exactly 1 degree in 1 hour. Okay. 1 degree per hour. So the angle theta will be exactly in t hours, it will be exactly the angle will be t degrees. Correct?
Yes,
Correct,
sir.
Pooja? Yeah. So if the angle is t degrees, okay, if you know the angle theta, then do you know what is the y coordinate? If I take this, let's say this the radius is 1, okay, radius of the circle is 1. So if I change the radius and rotate by theta, then what is this height from the x-axis, the y coordinate? What is this height? Can you see can you make out my hand? This is the x-axis, okay. This finger is x-axis. This is that circle, radius of the circle, which is 1. It is going up like that. It's going like this in a circle, okay. So now if this angle is theta, then what is the y coordinate? How high is this? What is this opposite side called? What is the opposite side? If this angle is theta, then what is the opposite side?
Sine theta, sir.
Sine theta, exactly. So which is sine of t. If the rotation is at 1 degree per hour, then t is exactly equal to theta. So it will be sine of t, correct?
Yes, sir.
Correct, Pooja? So as if you make t as the x-axis, then the y coordinate will become sine of the t, which is sine of the x-axis. Correct?
Yes, sir.
Okay. And then if you remember, now let me just project back the let me just show that figure we had shown from last week on the slides. So this is how the graph will look. So this is the time and this is the y coordinate. So the theta is changing with time in a straight line because theta is equal to time. but the y coordinate is going like a sine wave, up and down, up and down. So now, Pooja, do you understand now why, if something is going in a circle, okay, if you look at its y direction, height, vertical direction, that vertical direction actually will going up and down, up and down. Exactly like a spring, just like a spring goes up and down, up and down. You know, if you attach
Yes,
something to a
sir.
spring, it goes up and down. Similar, exactly up and down. And now, if you look at it as a function of time, it will look like a sine wave. Is that clear, Pooja?
Yes, sir.
Okay. There were some other people who had also said no. I want to make sure they have also understood. I think one of them was, I think Sahana was one of them. Is that right? Sahana, can you, Sahana, I forget
Yes, sir.
which Sahana. Do you understand after this explanation, why something if is going in a circle, then if you look at the vertical direction, it will, and if you look at it as a function of time, it will look like a sine wave. Do you understand? Sahana?
Yes, sir.
Sure? I can explain more. I can explain more if you have some doubts.
Yes,
Okay,
sir.
let me ask Akash Jakati. Akash Jakati, can you unmute your mic?
Yes, sir.
Akash?
Yes, sir.
Yeah. Do you have some confusion? Do you have something is not clear?
Yes, sir. Clear, sir.
Clear? Sure?
Yes, sir.
Can you explain in your own words why when something is going in a circle, then one of the coordinates looks like a sine wave? Can you explain in your own words, Akash? Yeah, keep saying.
Y coordinate of the moon origin is at the center.
Hmm. Yeah, then what happens to the y coordinate?
It is go up and down,
Yeah, go up and
move up and down, sir.
down. Exactly. Yeah. What is what is up and down function as a function of time? What is the formula? If I give you if your time, then
Negative
t, and the rotation is exactly 1 degree per hour, and t is in hours, then what is the y coordinate?
sine theta.
Akash? Sine t. Sine theta, but theta is equal to t because it's exactly, if it's going exactly 1 degree per hour, then theta is exactly t. So it'll be sine of t. Correct. Pooja Hubli. Pooja
Yes,
Hubli. Okay. Do you understand or not? Something is
yes,
not
sir.
clear or sure?
Yes, sir.
Sure. Okay. Sachin Korabet. Sachin Korabet. Can you unmute? Yeah. Do you understand, Sachin, or not, or something is not clear?
Understand.
Sure. Okay. Anyone else not understood? Just feel free to raise your hand or unmute and ask. Everyone understood? Okay. It's quite simple actually. Just going round and round like this. Now see how your eyes, what is happening as it's going up and down. Is it going up and down like this? Yeah, it's going up and down like that, right? See? This up and down is like a spring. If you just track the up and down, like a spring. Okay. All right. So the spring motion is also like that. Spring, if you go the way the spring, so last time we were talking about spring, right? If a spring, something is attached to a spring, then it goes up and down, up and down. Now, does anyone remember what is the force acting on the spring? Remember we said Hooke's law, something force acting on the spring, because of the spring on the object. If you attach a thing to a spring and you pull it, then how much force is there on the spring? Does anyone remember that? How does the force change with how much you pull it? Who remembers that? If I put it 1 centimeter, there'll be some force. If I put it 2 centimeters, there'll be some force. 3 centimeters. The more I pull, what will happen? Does anyone remember how the force changes with this, with the how much you pull it or push it? No one remembers? If you pull the spring more, what will happen to the force? Will it increase or decrease?
Increase, sir.
If I pull it 1 centimeter versus 2 centimeters, what will happen? Will it increase or decrease? Anyone remembers? If I had a rubber band, I can show. If I take a rubber band and I pull it, 1 foot versus 2 foot, how much force will I feel? Try rubber band. If anyone has a rubber band, just try. Take a rubber band and just stretch it. Or stretch it double, stretch it more, what will happen? Anyone remembers? Okay, let me ask some random person. Okay, Sahana, Benny, can you unmute?
Sir.
Yeah, so what do you think will happen if I take a rubber band, okay, big rubber band, let's say, and I pull it by 5 centimeters, and then I pull it another 5 centimeters, another 5 centimeters. What will happen to the force as you go on pulling?
It increases, sir.
Yeah. So if you don't pull it at all, what is the force? If you just keep it at normal, then does it exert a force?
No, sir.
No, zero. Force is zero. If I stretch it by 5 centimeters, there will be some force. If I stretch it double, then what will happen to the force? If I double the amount of stretch, then what will happen?
Again, force increases.
Increases. Now, does it increases if I double the stretch? Will the force also double, or will it become like, how will it change? The exact formula will be what? What is the exact formula for the force? Let's say I stretch it by x centimeters. Okay. Then is it proportional to x, or is it like, how do you think it changes? So first of all, it increases with x, right? The more I stretch, the more force I will feel. So it's clearly increasing with x. But is it proportional to x, or how does it change with x?
It is directly proportional, sir.
Yes. Okay. So in most springs, most rubber bands, there's something called Hooke's law. Okay. Hooke's law says that the force is directly proportional to the stretch. Okay. So let me just write that first. So stretch x. Okay. Force F is proportional to x. Okay. F is proportional. I don't know how to write proportional. Let me just try, see if I can insert that symbol. Oh yeah, proportionality. Okay. Okay, proportional to x. So force is equal to some k times x. Okay. Now, if x is positive, then the force will be positive or negative? If x is positive, will the force be positive or negative? If the x is in the right direction, if I pull it, stretch something in the right direction, the force on the hand will be on the left side or the right side? So let's say I have a spring in my hand, okay? And with this right hand, I'm pulling that string like this to the right. So if I pull to the right, then if the coordinate system, the x-axis right is positive, then the x is how much I move my hand, okay, from the origin. So I'm moving to the hand, let's say by 5 centimeters. So x is 5 centimeters. Now if I move to the right by 5 centimeters, then the force on the hand will be in the positive direction, the right direction, or the left direction. Which direction will the force be? Left or right? If I take hold of the spring and I move my hand to the right, so right is positive, let's say, then will my hand feel a force to the left or to the right? Okay, let me ask Sachin Korabet. Can you unmute, please?
Yes, sir.
Yeah, Sachin. So if x is positive means I took my hand is holding this whole spring, and I move my hand to the right. So x is positive, okay? So I move it by x centimeters. Then the force on the hand will be to the left or to the right? Which
Left,
direction is
sir.
the spring pulling me? Left. So the force is positive or negative? The force on the hand
Negative.
is positive or negative? Negative, exactly. So the force is in the opposite direction of which you stretch. Okay? If the force was in the same direction that you stretch, then what will happen to that thing? Suppose that I suppose that I move to the right and the force is also to the right. Then what will happen to this? It will keep going. It will accelerate. Correct? Imagine an object. If I move it to the right, it feels more force to the right. Okay. Then it will more accelerate to the right. Then it will feel more force. It will more accelerate to the right. It will keep going right. So the force is in the same direction as the displacement or where I move it. Then the object will keep accelerating to the right and keep getting faster and faster to the right. So it will never come back. So the reason it comes back is why? Because the force is, what is it, Sachin? The reason it comes back is because the force is pulling it in which direction?
Negative.
Left.
Left.
Negative direction.
Now, will it always keep pulling to the left? If I attach a body to the spring, if I attach some ball to a spring and I move it to the right and I leave it, will it always keep the force always be pulling it to the left? Always? Sachin?
Yes, sir.
It will always keep pulling it to the left? Will it always keep left? Will the object keep getting pulled to the left forever? Or will it sometimes, after some time, it will go, what will happen? Why will it change? Why will it not go? Why will it not get pulled to the left? So I take this. I have a wall, let's say here, and I have a spring here attached to this, and a ball here. Now, if I pull the ball like this, it feels the force to the left. Now, if I leave the ball, it will start going to the left, right? Now, what will happen? After some time, what will happen to the ball? Can you explain, Sachin, what will happen to the ball after some time? Can you think what will happen? Why does it start going? Okay, let's look at this. Let's look at this video. Okay, that will tell you what is happening. Do you see this video? Do you see this YouTube video screen? Okay.
Yes, sir.
So look at this. Okay, so there is this ball. You see my mouse here? There's this red object which is attached to the spring, and this is attached to the wall. And assume that this surface has no friction. Okay. Now see what is happening to the ball. What is happening to that red box? See? It is going right, it is going left. It's going right, it is going left. Okay. Okay. Now he leaves it. Okay. So now so initially the red box was here. Okay. This is x is 0. This is in the neutral position. Okay. So this is 0, let's say. And now when you move it to the right, x becomes positive. So 0 is when there is no stretch in the spring. The spring, whatever the normal length was, so you call that 0. Okay. This point is 0. And then you pull it to the right and you leave it. When you leave it, what happens? The force that pulls it to the left. Okay. As it goes to the left, does the force increase or decrease? Sachin, does the force increase or decrease as you move, as it goes to the left? So you pulled it to the right, let's say by 5 centimeters, and then you left it. Now, as it goes to the left, what happens to the force? Does it increase or decrease?
Increase,
in
sir.
magnitude. So you pulled it, let's say 5 centimeters. Okay. At 5 cent, now it starts going from 5 centimeters to 4 centimeters to 3 centimeters to 2 centimeters like that. So at 5 centimeters the force is more, or at 4 centimeters the force is more, or at 3 centimeters? Which one is more, Sachin?
5 centimeter more, sir.
Yeah, 5 centimeters is a very strong force. Then at 4 it becomes less. Then at 3 it becomes even less. At 2 it becomes even less. At 1 it becomes even less. At 0 the force becomes 0. Okay. Correct?
Yes, sir.
So then what happens then? So why does it start going to the right? Why does the object start going to the right? See, look at this again. Okay, see. See, this is the x equals, this is the stationary position. Okay, when x is equal to 0. Now you start increasing. So it's got going x equals 0, then x becomes positive, then it becomes negative. Okay. So why does it go to the, so initially x is equal to 0. Now you made x positives. Let's say you made 5 centimeters. And then you left it. Okay. And there's a force. Now the force makes the object accelerate to the left. Accelerate. Okay. What happens after that? Why does it start moving to the right? Why does it go left and then start moving to the right? Can someone think why it would go to the right? Think of a swing. Have you gone on a jhula, right? On a swing. Okay. If you push, you come from the one end of the swing. If you leave it, what happens? It goes down, 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 down. Because the gravity is pulling it down, right? Gravity is pulling down, so the spring goes down, 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 down. But then why does the spring go? Why does the swing, the jhula, why does it go up? Why does it go up, back? So I took the jhula and I took it to the right and I left it. So the jhula goes down, 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 down. But does it stop when it comes down? Does the jhula stop when it comes down?
Sir,
In the jhula is the
because
same
of
thing, right? The more you pull to the right, the more the force is the more the gravity force is pulling it down. The more up on the right it is. It's more moving it to the left. Yeah, go ahead. Someone was saying something. Who was speaking? Can you continue speaking? Because the what?
frictional force, sir.
Frictional force. In jhula, because of frictional force. So in jhula, what is there? In a swing, you have a swing, and the person is sitting on the swing and it's tied to some up there, right, on the pole somewhere. And some other person pulls that person's jhula to the right. Okay, and then leaves. And the jhula goes down, 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 and then it goes left, left, and then stops, and then come down like that fast goes. So the gravity is pulling it when it is up here. It is pulling it down, right? Down means pulling it to the left because it can't go down because the thread, the string, is attached to the pole, so string can't extend. So the down becomes like a leftward force. So it goes left, 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 left. Now, why does it not stop here? Why does the jhula not stop here? Now there is forces down. So why does it go to keep going to the left? Once it reaches the bottommost point, why does it keep going left and go more up on the side? Same thing with a spring. If I take an object, I pull it 5 centimeters. Why does it not stop after coming back to 0? Why does it go more to the left? So first the string has been expanded by 5 centimeters. And then the spring keeps pulling it to the middle. And the spring gets compressed. Why does it get compressed? Why does the object keep going to the left? Why does it not stop? See, I can show it with this. You can show it with this also, see? Okay. Let me show. Now just look at my thing. Okay, so this is like a swing, okay? Okay, it's like a charger, but it's like a swing. Now I take it to the right. Gravity is is the gravity going to cause it to go left when I leave it? Will it make it go left? Okay, is it going left? Is it going like this? Left? Correct? My left, okay, my left. So the gravity is making it go left. Now, when it reaches here, the gravity is going to pull it down. So it is not going to go. Why does it keep going to the left after it has reached here? Why does it not stop here? So this is normal position, right? This is neutral position. This is equilibrium. The string is pulling it up. Gravity is pulling it down. And this is because the string force is equal to the gravity force. This is not moving. So when I leave it from here, why does it not stop here? Come down and stop here like this. Why does it go more to the, see, more to the left? And then right, more, left, right, left, right. Why is it doing that? So why does it just stop when it comes exactly vertical? Why does it go more like this? Same thing with the spring. Spring also same thing happening. This is the neutral position. You stretch and it goes right. When you leave it, it doesn't come back and stop here. It actually compresses the string. It makes the string smaller. Okay. And then comes back here and again makes x positive, stretch. Again comes back, makes x equal to 0, and then x negative, and then again x negative, and then compress. Same thing like this jhula. Okay, you go pull it right. You leave. When you leave it, the gravity is pulling it down, which makes it go left. Okay, goes left, 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 but it doesn't stop here. It keeps going. Why does it keep going? Why does it keep going left, 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 left? Who can tell why it keeps going left, left, left? The spring also goes left. The object, that box also, that red block also goes left, left, left. And the swing also goes left, left, left. Why does it do that? Anyone has any idea? Take a guess. You don't have to be correct. Just take any guess. Just say anything that comes to your mind. Okay, it doesn't have to be. Don't worry about it being wrong or right. Just take some guess. Why should the jhula or the spring object or whatever it is, why should it go more left than where it normally was, the normal stationary position? Why does it go more to the left? And then again comes back and goes more to the right. And again comes back, goes more to the left. Why does it do that? Yeah, Pradeep, go ahead.
Force applied by us is more than gravitational force.
Repeat that again. Force applied by? Repeat,
Than
Pradeep.
gravitational force. Force applied by
Force
us
applied by
is
whom
more
is-
than gravity.
But see, look at here, okay? Look at this thing I was showing. Okay. I just pulled it to the right. Okay. So here I pulled it to the right by applied a force to pull it to the right. Okay. But when I leave it, now there is no force applied from me, right? Now there's no force applied from me. So why does it not just come back to the original position and stop? See, this is normal position, right? It should stop here. But if I pull it, it doesn't just come till here and stop. But it comes here and it goes all the way more that side. In fact, it goes, if I pull this by 30 degrees, it goes again that side 30 degrees. Then again comes back, again goes 30 degrees. Again this side 30 degrees. Keep doing like that. So like a clock, it goes going. See? Okay, it's decreasing. Slowly the angle is decreasing because of the air friction. But if there was no air friction or like air or anything like that, it will keep on going. Like a clock pendulum. So at this, like once I leave it, am I putting force, Pradeep? Once I leave it, am I applying force? I was applying force to pull it to the right beginning. But once I left it, then I'm not applying force. Then only the gravity is applying force. Pradeep?
No, sir.
Correct. So if the gravity is now once the object is reached here, gravity is pulling it down, right? Correct. If the gravity is pulling it down, is there any force that is making it go to left? So Pradeep, when it is 30 degrees, is the gravity causing it to go left? How is the gravity
Yes,
causing it to
sir.
go left? How? Gravity is down. Why is it going to the left? Which thing is causing it to go to the left? There are two forces acting on this: the gravity and then this thread force. This thread force is pulling it in which direction? Where is it pulling it?
Left side.
Up and left. Yeah, up and left. So this is going up and left. Gravity is down. So the gravity is down kind of cancels this one's up. So the left side remains. So this is causing it to go left. But when it reaches here, this is pulling it up. Gravity is pulling it down. So why is it going left? Is there any, when it is in this position, is there any force pulling it to the left? Or force is only up and down? This force is up, gravity is down. So why is it going left? Why does it keep going left? Why doesn't it just stop there? Pradeep, take any guess. Doesn't matter. Don't worry about being wrong.
That force might be much stronger than the gravitational force.
Which force? Which force might be much stronger?
The up and left force.
But when it is vertical, is there left force? See, here I understand. When it is 30 degrees, then there is up and left force here, right? There's up and left force. But when it is 0 degrees, when it is vertical, is there up and left force or only up force? from this thread? From this thread, is it only up force or up and left force?
Up and left force.
When it is full vertical, where is the left force here? This thread is doing left force or only up and left force or only up force? Is it up force or only only up force or up and left force? Is this thread causing up force or up and left, Pradeep? See, look at this here. Is there left force on this object right now?
No, sir.
Only up force. Up force from the thread, from the string, and down force from the gravity. And the two cancel each other. That's why this object is in rest. If they didn't cancel, then the object would move. Okay. So if this object is in rest, has only up force, then why was it going to the left? See, when I release it, it doesn't stop here. It keeps going to the left. See, it keeps going left. It comes here and it keeps going left. Why does it go left? Pradeep?
Sir, up and down for gravitational force cancel each other.
Yes. Then why is it going left? Why do things go in a certain direction? Why do things go to the left? Why does anything go in any direction? If there is no force acting in a certain direction, so in the left side there's no direct force, right? Then why does it keep going in that direction? Should I give you a hint, Pradeep? Do you want me to give you a hint? Or you want to think more? If there is no force acting towards the left, does that mean the object will not go towards the left? Yeah, Pradeep, you were trying to say something? Don't worry about being wrong, okay? Just say anything, whatever comes to your mind. Think about when you're playing cricket, you throw a ball, okay? You throw a ball in the air. You throw a ball in the air, okay? Let's say you throw at some 45-degree angle. The ball goes like this, right? Correct? You throw a ball, it goes up, 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 comes down. Is it going to the left? Is it moving? Is it only going down directly, only going up, down, or is it also going to the left? Pradeep?
Sir, also going to left.
Why does it go to the left? Is there any force acting towards the left? After you leave the ball, is there any force acting to the left? Once you have left the ball?
No, sir.
Then why is it going to the left? Why does it not stop and only go down straight? Why does the ball keep going to the left? The speed of the ball to the left, does it change or does it not change? Let's say there was no air, okay? There was no air at all. Then will the speed of the ball towards the left, will it change or not change?
Sir, change.
It will change? Why will it change? The speed only to the left direction, not in the up-down direction. Up-down direction, just in the x-axis. If you just look at the speed on the x-axis, how much it is going to the left, 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 left. Will it change the speed in the x direction? Why will it change, Pradeep?
Sir, as time period increases, force also increases.
But force is the gravity force, right? The gravity force is pulling it down. So why will the speed in the left direction? So it is moving. So speed has the velocity has two components, right? The velocity has left, 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 and down, 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 down. So the velocity in the left direction, will it increase? Or only velocity in the down direction increase? Okay. Why will the velocity in the x direction? What will be the velocity? Why is the velocity in the x direction not zero? Why is it going to the left? There is no force acting in the left direction, right? Why does a cricket ball that you throw, why does it keep going to the left? Why doesn't it just stop after when you leave it from the hand? Why does it keep going? Why doesn't it stop? Should it stop suddenly in the middle? Should it go like this, and just suddenly stop and then come down? Pradeep? Or it should just keep going to the left with the same velocity towards the left? Anyone, feel free to answer. Okay, Pradeep, anyone? Pradeep, you can also answer. You don't worry about being wrong. If I throw a cricket ball, like this, it doesn't just go down. It goes left, 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 and then down. So it keeps going to the left. Why does it keep going to the left? There is no force pulling it to the left. Madhumita Pujar, maybe you want to try? Do you want to take a guess? Don't worry about being wrong. Can you unmute Madhumita?
Yes, sir.
Yeah. Why does a ball, if I throw a ball like towards the left like this, okay, the gravity force is acting towards down, right?
Sir.
Why doesn't the ball just go down straight? Why does it go to left, keep going to the left? Madhumita. Don't worry about being wrong, okay? Just think whatever, take your best guess and just answer that.
Sir, can you repeat?
Okay, so if I take a ball, okay, if I take a ball and I throw it like this, okay, in the air in the left direction, let's say from a building, okay, I throw it like this from a building. Now, once I throw it, how does the ball go? The ball goes like this, like this, like this, like this, like this, like this. But the gravity is going to pull it, only pulling it down. Then why doesn't the ball just fall down straight? Why does it keep going left, 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 left?
Sir, because of force.
Because of what?
Force, sir.
So, but once I have left the ball from my hand, okay, so I left the ball here. I moved like this and I left it here. Okay, I moved it like this and I moved it here. Now, when it is going after some time it has gone there. 2 seconds, 3 seconds, down, then finally after 10 seconds it might hit the ground. But when it is in the air, is there a force? Which direction is the force acting in Madhumita? In which direction is the force acting? Which force is acting and in which direction? Madhumita?
Sir, left side.
When it is in the air, is it in the left side? When I'm not touching the ball, okay? I've left the ball. The ball has left my hand. Let's say it's become 4 seconds, 5 seconds has happened. It's still in the air. Then what force is acting on the ball? Madhumita? Is my hand touching the ball?
No, sir.
Then what force is acting on the ball? When it is in the air, which force is acting on the ball, Madhumita? Tell me any force that is acting on the ball when it is in the air.
Sir, gravitation force.
Yes. And gravity is in which direction? Gravity is in which direction?
Sir, upward.
No, gravity is down, right? It's pulling it down. Correct?
Yes,
It's a vertical
sir,
force
downward.
pulling it down. Correct? And that's why the ball keeps going faster and faster down. So if you look at it, look at the vertical velocity. The vertical velocity goes on increasing, so it goes faster and faster to down. Okay. But then why does it keep going to the left? Is there a force that is acting on the left, towards the left? Is there some force? Is your hand touching it and pushing it to the left, putting it to the left again over as when it is in the air?
No, sir. No, sir.
No. Then why does it keep going to the left?
It requires some time to decrease the given velocity. So you apply some velocity. You give some velocity to that ball, no, sir.
Yeah, when you left, when you were moving your hand, you are giving it some velocity towards the left. That is true. Okay. So let's say some 10 kilometers per hour speed. Okay, 10 kilometers per hour speed, it was left. So what will happen to the velocity over time? Will it decrease over time? The left velocity. Let's say there is no air. There's no air in there. There's no air. There's nothing. No friction. Nothing. Then what will happen to the left velocity? If you look at the x-axis and plot where the ball is in the left x-axis, will you still keep seeing at 10 kilometers per hour, or it will decrease with time after it left your hand?
It decreases.
Will it decrease? If there is no air, will it decrease?
Yes, sir.
If I take a ball and throw like this in space, there's no gravity. Will it keep going to that direction for same very speed, or will it decrease?
Sir, no.
No, yes, sir. Tell me just which one do you think it is? It is no, or will it decrease or not decrease?
Not decrease, sir.
Why will it not decrease? Why will it not decrease, Madhumita?
So because
Yeah, you're right. It will not decrease. But why? Keep thinking. Keep tell me why.
because there is no gravity.
Okay, so
So it will
why does it
not
not
decrease.
decrease? Why will it not decrease? Why doesn't it stop after some time? Slowly. Why doesn't it come to stop?
So because in space there is no gravity, no, sir.
And in Earth, if there is gravity and there is no air, no friction, nothing, then will the speed of the ball decrease towards the left? The horizontal velocity will it decrease over time? Madhumita, will the horizontal velocity decrease? If I take a cricket ball and throw it with 10 meters per second, 10 kilometers per hour, and there is no air, nothing friction, will the horizontal velocity decrease over time?
No, sir.
Why will it not decrease?
There is no air resistance.
Yeah. So why does it not decrease? If something in space, why does it not decrease? So why should it not decrease? If an object is moving, why doesn't it just stop after some time?
There is no gravity, there is no air resistance, and
Yeah. So why is it that when objects are moving, after some time, if there is no gravity, no everything, why does it not stop after some time? Why does it keep going? Even if there is no resistance, no gravity, shouldn't it stop after some time? Should it stop after some time or should it not stop after some time? Should something stop after some time? If there is no force, no resistance, no friction, should things stop after some time or should they keep moving? Will they keep moving or will they stop after some time? In space, will something keep moving in the same direction, same speed, or will it stop after some time? Why does it not stop after some time? If there's no gravity, no friction, nothing, why does it not stop after some time? What is it? What is that word called? What is that principle called? Anjali?
yes, sir.
Yeah. In space, if I throw an object, why does it not slow down after some time? Why does it keep going? There's no force, there's no friction, there's no gravity. Why does it keep going? What is that word called? There's a specific word for it. Something that is in motion will continue. If something object is in motion, it will continue in motion unless acted upon by a force. Can someone remind this? Does someone remember this? Can you tell me what is that word called? Something is in rest, it will keep being in rest. Something is in motion, it will keep being in motion. Whatever speed it was there, it will keep having that speed, the same direction.
The inertia, sir.
Exactly. Yeah. Which law of motion is this? Which law of motion?
First law of motion.
What does the first law say? The first law says that if something is moving, if you don't apply any force, it will keep moving in that same direction, the same speed. You have to apply a force to bring it to stop or to increase its speed or to change the direction. So a cricket ball, if it is going to the left and in the air, when I'm not touching it, will it suddenly slow down in the left direction or will it keep going in the left direction at that same 10 kilometers per hour speed? Will it keep going ahead or will it stop? What happens to cricket ball? In the air,
Keep going.
keep going to the left, same speed. The left velocity doesn't change. The down velocity goes on increasing because of gravity. Okay, the down direction will go on, the velocity go on increasing. But the left direction stays the same. And now let's look at this again, this thing against this. Okay, here, okay, it gets pulled to the left. It has a high speed here. It is a high velocity to the left. Now there is no force acting to the left, but will it stop? Will this thing stop or will it keep going to the left? Right? There's no force, there's only up and down force. There's no force to the left. Will this thing stop? Or whatever speed it had to the left, will keep going with that speed. So by the time I left it, there was a force pulling it left. Because that force, its velocity got increasing. It got some velocity, and that velocity suddenly can't become zero suddenly. It will keep going to the left. And as it is going to the left, it will start getting pulled to the right. Why? Because now gravity is pulling it to the right. It's pulling it to the right. It will slow down, and then its velocity will become zero, and then it will go on increasing in this direction. And then it'll come back here. But when it comes here, it's not going to stop. Why? Because it has inertia. Because of inertia, it has some velocity. So it'll keep going to the right. And like that. Same thing with the spring. The spring also. Okay. When you stretch it, it comes back to the point where it was originally. It is not going to stop there because it has some high velocity. So velocity is because of inertia, it'll keep going to the left and it'll go in the opposite direction. It'll make the spring to actually become smaller. Spring becomes smaller, and at some point the spring force becomes so big that fully stops. And then it goes again to the neutral point, and then again right. Okay, do you understand that? Do people understand this point?
Yes, sir.
Okay. Okay, let's close for today, and then we can continue next time.
Yes, sir.
Okay, thank you.
Thank you, sir. Bye.